Hi everyone, welcome back to another video. We will be solving paper 2, variant 1 for May-June 2018. So let's start. Question number 1 is use set notation to describe the shaded region in the Venn diagram. So the shaded region is outside of these two sets P and Q. So that means it is outside P union Q. So P union Q will be everything in P and Q. So this is P union Q. And since the shaded region is outside, I will take the complement of this. So P union Q complement is the uh, shaded region in this Venn diagram. The next part is your universal set is the numbers from 1 till 12. A is a set of numbers where each number is a factor of 12. So let's write down the factors of 12 here from this universal set. So 1 is a factor of 12, 2, 3, 4, and then 6 is a factor of 12 and 12 itself. B is a set of numbers which are multiples of 2. So we can write the multiples of 2 out of these. So these will be 2, 4, 6, 8, 10, and 12. And C is a set of numbers which are square numbers. So which numbers here are square? So 1 is a square number, 1 square is 1. Then 4 is also a square number, 4 is a square of 2. And then 9 is also a square number, 9 is square of 3. So these are the numbers in each of these sets A, B, and C. The next part is show this information on the Venn diagram below. So we will start with the innermost intersection where all these three sets intersect, A, B, and C, all three intersect here. So that means we have to find a number that is common in all three of these sets. So let's start with this one. So 1 is not present in this. 4 is present in all three. So 4. And then 9 is not present in all three. So this will be our intersection of A, B, and C. So let's now move on to the intersection of A and B. So intersection of A and B means numbers that are present in both A and B. So you have 2 present, you have 4 present in both, but you have already written 4 here. Then you have 6 that is common, so 6 and then 12. And then let's look at A intersection C. So A and C, they have 1 common, 4 is already written here, and then 9 is not present in A. Then let's look at B intersection C. B intersection C, so 1 is present in this, 1 is not present in B, 4 is present here, we have already written 4, 9 is not present, so this is empty. And then let's move on to the rest of the numbers, so remaining numbers in A. So you've already written 1, 2, 6, 12, and 4, so the remaining numbers from A are 1 is written, 2 is also written, 3 is missing, 4 is already written, 6 is already written, 12 is already. So 3 is the only number here, which is part of set A, but not part of any of these intersections. Now let's look at set B here. So you already written 2, 4 already present here, 6 is already here, 8 is not, so we write 8, 10 is also missing, so 10, and 12 is already written here. And let's move on to C here. 1 is already here, 4 is already here, 9 is missing, so we write down 9 here. And then we have to write down any numbers outside these three sets that are not part of this set here. So since these are continuous numbers from 1 till 12, so you have 1, 2, 3, 4, 5 is missing, so 5, 6, 7 is also missing, so 7. In fact, I can just write 7, 8, 9, 10, and 11 is missing, so 11 will be outside here as well. So just to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I have written all the numbers that are present in the universal set. So the next part is find the number of elements in A intersection B. So A intersection B is this region that is part of both A and B. And how many numbers? So the question asks for the number of elements. So 1, 2, 3, 4. So you have four elements that are in the set A intersection B. So just let me rewrite this. The next part is find the number of elements in A intersection B union C complement. So we'll start from the innermost, B union C. So let me highlight B union C here. So B union C is everything inside of B and everything inside of C. So this is B union C. And then complement is everything outside of this red, red boundary that I have drawn. So B union C complement will be outside of this red boundary. And then you have to find the intersection with A. So everything outside intersection with A. So A is this one here. So the common region that is outside of this red. So everything outside here is B union C complement. So what is the common region between this green, inside this green, but outside this red? So since we are looking at A, so A is this green, and you have to look outside of this red region. So the common region, let me mark this in yellow here. So this is the common region that is outside red but inside green. So the only element in this region is 3. The question asks you to find the number of elements. So number of elements here will be 1. The next part is one subset in the Venn diagram in part B1 has no elements. Use set notation to describe this subset. So the subset that is empty in this Venn diagram is this one. So let me just erase this one from the previous part. This was a, all right. So now you have to find the set notation for this region, which is empty. So this is an intersection of B and C. So B intersection C will give you this full region, but I'm only looking for this shaded region. So this is outside of this set A. So that means I have B intersection C, which gives me this full blue boundary. And then to eliminate this region, so I want to eliminate this red region. So I'm basically looking for the intersection of this blue region with A complement, because this shaded region is outside of A. So this is outside of A. So the common region between this blue, which is B intersection C, and A complement, which is outside of A, the common region is this one. This is outside A and it is part of B intersection C. So you get B intersection C, then intersection with A complement. So this is the region that you will get, which is empty. The next part is write 540 as a product of its prime factors. So let's find the prime factors for 540. This is divisible by 2. So 2 2s are 4, 7, 0. Again divisible by 2. We'll get 2 1s are 2, then 3 6, 135. And then this is divisible by 5. 5 2s are 10, 335, 7. And then this is divisible by 3. 3 9s are 27, 3 3s are 9, and then 3 1s are 3. So 540 can be written as 2 power 2 multiplied by 5 power 1 multiplied by 3 power 3. So you have three threes here. So your answer here will be 2 square multiplied by 5 multiplied by 3 cube. P is the smallest possible integer such that 540 multiplied by P is a square number. Find the square root of 540P, giving your answer as the product of its prime factors. So you have, in the previous part, you found out that 540 is this 2 square multiplied by 5 multiplied by 3 cube. Now, when we multiply this number 540 with this number P, you get a square number. So that means 540 when multiplied by P will give you a square number. So once I do the multiplication, so I'm writing 540 as it is, and now I am multiplying it by P. So now I have to make this a square number. That means the powers of all the prime factors should be even. So 2 square to the power of 2 is already even. 5 has a power of 1, so I will multiply it by 5 to get 5 square. 3 has a power of 3, so to make this power even, I will multiply it by 3 power 1. So 540 times P will become 2 square multiplied by 5 square multiplied by 3 power 4. Now every power is an even number, so that means this is a square number. I can also multiply here by, let's say, 5 power 3, which will make this 5 power 4 when I multiply this 3 with this 5 power 1. But the question says that you have to find the smallest possible integer P. So the smallest possible integer is the minimum number that we need to multiply here to get these powers even. So higher powers are also even, like 2 power 4, 5 power 6 is also even, but you have to find the smallest possible number. So you will multiply with the smallest possible numbers to make the powers even. So we don't multiply with 2 because it's already even. 5 power 1, so to make it 5 square, we just multiply it by 5 power 1, and 3 cube can be converted into 3 power 4 by multiplying it by 3. So this is 540 times P is this. Now the question asks you to take the square root. So 540P square root will be square root of this. So 2 square into 5 square into 3 power 4, and square root is power 1 by 2. So once I open the bracket, I can bring the power inside. So the powers will be multiplied. 2 multiplied by 1 by 2 will be just 2 power 1 multiplied by 5 square. So this 2 multiplied by 1 by 2 will give you 5 power 1 as well. And then this is 3 power 4. So 4 into 1 by 2 will give you 3 square. So square root of 540p in terms of the product of its prime factors is 2 into 5 into 3 square. Question number 2 is Sami invests $2,000 in an account paying compound interest at a rate of 1.8% per year. Calculate the total interest paid to Sami after 3 years. So we can find the amount in the account after 3 years. So using the formula for the compound interest, which is P, where P is the principal, into 1 plus rate over 100 power n, where n is the number of years. So your principal is $2,000. 2000 into 1 plus your rate is 1.8% over 100, and the time is 3 years. So let's calculate this. 1.8 divided by 100 plus 1 and power 3, and then multiplied by 2000. So this is 2109.96. So $2,109.96. So this will be the amount in the bank after 3 years. So the difference will give you the total interest that was earned during these 3 years. So interest will be the final amount in the bank after 3 years minus the principal amount which was invested at the start. So this was 2000. So the difference will be $109.96. So this is the interest earned, 109.96. Part B is Theresa takes out a loan. She repays the loan over 1 year at a rate of $54 per month. The total she repays is 8% greater than the value of the original loan. Work out the value of the original loan. So let's say the original loan is X dollars, and then the loan that Theresa loan repaid is how much? $54 per month she pays for 1 year. So that means 54 into 12. So 54 into 12 is $648 is the loan she repaid. And you're given that the loan that is repaid is 8% greater than the original loan. So that means this is 8% greater than X, or you can say it is 108% of X is the loan repaid, which has value of $648. So 108% of X means 108 over 100 multiplied by X equals to 648. And from this, we can find the value of X. So I'll take this 100 and 108 to the other side. So 648 multiplied by 100 divided by 108. So the value of X is $600. So your original loan was 600. Question number 3 is solve this equation. So I will open the brackets on the left side. I will get 4p minus 12 equals to 2p plus 7. And then I'll bring this 2p here and take this 12 to the other side. So 4p minus 2p will be 7 plus 12. And then 2p will be 19 and p will be 19 divided by 2, which is 9.5. The next part is solve these simultaneous equations. So you can use the substitution method or the elimination method. I'll use the elimination method. So this is my equation 1, this is equation 2. So I will multiply equation 1 by 2. So I will get 2 times 2, 4x minus 2y equals to 10. And the other equation is 7x plus 2y equals to 1. And then I can simply add these two equations, which will eliminate this variable y. So 7 plus 4 is 11x, 2y minus 2y will be 0, and 10 plus 1 is 11. And this will give you x equals to 1. And now you can substitute x equals to 1 in any equation. I will substitute it in equation 2. So substitute, put x equals to 1 in equation number 2. So this will be 7 into 1 plus 2y equals to 1. 2y will be equal to 1 minus 7. 2y equals to minus 6, which gives you y equals to minus 3. So x equals to 1 and y equals to minus 3. The next part is simplify this. So in the numerator, I can take m common. So m into m plus 3. And in the denominator, I have this quadratic equation which I can factorize. So I have minus 3 here, the constant, and the coefficient of m square is 2. So minus 3 into positive 2 equals to minus 6. So since this is a negative sign, I need two factors of 6, which if I subtract, I should get this number 5. So 6 and 1 are the two factors that I'm looking at. 6 minus 1 is 5, and 6 times 1 is 6. So I will have 2m square plus 6m minus m, 6 minus 1, so and then minus 3. So 6m minus m will give you 5m again. So then let me continue here. The numerator remains the same, and in the denominator I will take 2m common. I will be left with m plus 3. Oops. M plus 3, and then I will take minus 1 common, and I will have m plus 3 here as well. So then I can take numerator again remains the same. In the denominator, I will get m plus 3 times 2m minus 1. This m plus 3 and m plus 3 cancel out, and then I'm left with m over 2m minus 1. So this will be your final answer. Part D is b is directly proportional to the cube of a. So b is directly proportional to a cube. So that means b equals to some constant k times a cube. Given that b is equals to 4 when a equals to 2. So b is 4 when a is 2. So we can find the value of k from this. 2 power 3 is 8. So k will be 4 over 8, which is 1 by 2. So your equation will become b is equals to 1 by 2 multiplied by a cube. Find b when a equals to 5. So b when a equals to 5 means 5 power 3. So 5 power 3 will be 125 over 2. 125 divided by 2 will be 62.5. So B is 62.5. So question number 4 is trigonometry. 12-letter tiles spelling the word trigonometry are placed inside a bag. A tile is taken at random from the bag. Find the probability that the tile shows the letter R. Give your answer as a fraction in its simplest form. So probability that you get R. So these are all placed in a bag and you randomly pick one out of these. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 total tiles, and how many out of those 12 are letter R? So 1 and then 2. So your probability of picking a tile with letter R is 2 over 12, and since you have to give the answer in simplest form, this will be 1 over 6. Part B is all the tiles are placed back in the bag. A tile is then taken at random and placed on the table. A second tile is taken at random and placed to the right of first tile. A third tile is taken at random and placed to the right of second tile. Find the probability that in the order the tiles were placed on the table, they spell GET. So this is without replacement. You take a tile out and you place it on the table, and then you picked a second one, you placed it to the right of the first one, and then again without replacement you picked the third one and placed it on the right side of the second one on the table. So this is without replacement. You have to find the probability that you get the first one is G, the second one is E, and the third one is T. So the probability that you get G, and in the second one you get E, and in the third one, so not GET, let me say, probability that first is G and second tile is E and third uh, tile is T. So when you're picking the first one, what is the probability that you will get G? So you have 12 tiles when you're picking the first one. You have 12, all 12 in the bag. Out of those 12, only one is G. So that means probability of getting G on the first try is 1 by 12, and means you will multiply. Now you are left with 11 tiles in the bag. You have picked this G out. Now the next one you're looking for is getting an E. How many E's are there? 1. So probability that second is E is 1 over 11, because you were left with 11 tiles after you picked the first one, and out of those 11 left in the bag, only one is the letter E. And now what is the probability that third is now T? So now you have picked G in the first try, E in the second. How many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you have 10 left. So your denominator will be 10. And what is the probability that the third one is T? So out of these 10, how many are T's? 1, 2. So the probability to get T now is 2 by 10. So this is the probability that first one is G, second one is E, third one is T, so that you spell GET. So This will be 2 in the numerator, 2 times 1 times 1, and in the denominator you will get 12 into 11 into 10, which is 1320. I can simplify it by dividing it by 2, so I will get 1 over 1320 divided by 2 is 660. So your answer is 1 over 660. Part C is vowels are letters A, E, I, O, U. All other letters are consonants. All the 12 tiles are placed back in the bag and 2 tiles are taken at random again without replacement. Complete the tree diagram below. So when you're picking the first tile, your vowels, you have a probability of 4 by 12. So we can confirm that as well. So now you're back with all the tiles in the bag. They're all in the bag. And how many are vowels inside? So A, E, I, O, U. I, O, E, and this O. These 4 are vowels. So once all the 12 tiles are in the bag, what is the probability that you will pick a vowel? 4 over 12. So vowel is 4 over 12 in the first tile, and the remaining 8 are consonants. So the probability of picking a consonant is 8 over 12 in the first tile. Now, if you pick one of the vowels in the first tile, you are left with 3 vowels and 11 total tiles. Your probability of picking a vowel in the second tile is 3 over 11. And what is the probability of picking a consonant in the second tile? You still have same number of consonants because you didn't pick one in the first attempt. So you have 8 consonants remaining out of the total 11. And if you come down here, so you picked the first one as consonant. Now what is the probability that the second one is a vowel? So you have all 4 vowels remaining in the bag and your total tiles are 11, so 4 over 11. And here you've picked the consonant in the first try, so the remaining consonants are 7 and the remaining tiles are 11. So picking a consonant on the second tile is 7 over 11 if you picked the first tile and it was a consonant as well. So the second one will be 7 over 11. So one less consonant remaining and one less total number of tiles. Find the probability that the tiles both show vowels. So both show vowels mean you go this branch and then this branch. So you get a vowel in the first tile and the vowel in the second tile. So that means you have to find the probability of getting a vowel and a vowel second try as well. So that is the probability, this 4 by 12 multiplied by this probability, which is 3 over 11. So this will be 12 over 12 into 11. 12 over 132, and I can simplify it. This will be 1 over 132 divided by 12 is 11. So 1 over 11 is the probability that both the tiles are vowels. Part 3 is find the probability that one tile shows a vowel and one tile shows a consonant. So I'll remove this. So now you have to find the probability one tile vowel and one tile consonant. So how can you get one vowel and one consonant? That means if you get vowel in the first tile and consonant in the second tile, or you can get one vowel and one consonant if you get the consonant in the first tile that you pick and vowel in the second. So these are the two probabilities that you have to add. There's an or here. So what is the probability that you get vowel in the first and consonant in the second? So vowel in the first and then consonant in the second tile. So 4 by 12 multiplied by 8 over 11. So this here will be 4 by 12 multiplied by 8 over 11, or you get consonant first and then vowel in the second one. So consonant first and then vowel in the second tile. So this will be 8 over 12 multiplied by 4 over 11. So 8 over 12 multiplied by 4 over 11. So this is 32 over 132 plus 32 over 132, which is 64 over 132. And I can simplify it. It's 16 over 33. So this is the probability that when you pick two tiles, one of them is a vowel and the other one is a consonant. Question number 5 is you're given a sequence. Find an expression in terms of n for the nth term of this sequence. So when you move on to the next term, you're adding 6 here, and then you're adding 6 here as well. So the difference is 6. So your first term is 1. Your second term is 1 plus 6, which is 7. And then your third term is 1 plus 6, which is 13. So you can either use the formula for the nth term, which is a plus n minus 1 into d, where a is your first value in the sequence. So this is 1 plus n minus 1 into d is the difference, which is 6. So you will get 1 plus 6n minus 6, which is equals to 6n minus 5. Or if you want to like expand this and see, find the formula, find the expression for the nth term using this expansion, you can do that as well. So you're looking at 1 as the first term here. So each time in the next sequence, so T4 will be 1 plus 6 plus 6 plus 6, right? Which is 19. So every time you add a 6. So for the nth term, you will have 1 plus. So for the second term, you added 6 one time. For the third term, you added 6 two times. For the fourth term, you added 6 three times. So you're adding 6 one less times than the term number. So for 4, you're adding 6 three times. So for n, you will add 6 n minus 1 times into 6, which is the same as this, which will, if you expand, if you open the bracket and simplify it, you will get the same answer. So this is like a more intuitive way of doing it using expansion and seeing how the sequence is formed. Next part is explain why 251 is not a term in this sequence. So you can find the term numbers, which is n, using this 251. So your nth term is given by 6n minus 5, and we equate it to 251 to see what is the value of n. So 6n will equal 256, and n will be 256 divided by 6. So this is 40. Let me actually write it up here. So this gives you n equals to 42.67. So n is actually the pattern number or the term number, right? So n cannot be a fraction. So you can say that 256 is not divisible by 6, as shown here, is not divisible by 6. So it gives fractional value, fractional value, uh, fractional value for the pattern number. So your pattern number n here is coming out to be a fractional value, which is not possible. You have the first term, the second term, 42nd term, 43rd term, but you cannot have a 42.67 term. So that is the reason 256 here is not divisible by 6. So 251 that we equated here cannot be a term in this sequence because it gives a fractional value for the pattern number or the sequence number. Part B is, here is another sequence 5, 8, 13 and so on. The pth term of this sequence is p square plus 4. Write down an expression in terms of p for the pth term of these sequences. So we have to use this to find the pth term of first this sequence. So if you look at this sequence, uh, if you look at the first term, you subtract 7 to get -2. You get again subtract 7. 8 minus 7 is 1. 13 minus 7 is 6. So it basically just subtracting 7 out of this sequence to get the corresponding term in this sequence. So for the pth term, you have p square plus 4 here, and then you will just simply minus 7 to get the pth term for this sequence. So this will be p square minus 3. And so let me just erase this. So if you look at the next sequence, uh, so let me actually write down, let's call this T1. This is 7. So I'm basically adding 2 to the first 2 to the term, this first term of this sequence. So 5 plus 2. So I added 2 to get this. So the second term is 12. So let's compare the second terms here. So now I'm adding 5 plus 2, 7, which is the previous term. Oh no, I'm actually comparing these two. So I added 2 to the first term of this sequence, which is 5. I added 2 to get 7. So the second term in this sequence is 8. And now I have to add 4. So 8 plus 4 is 12. Let's look at the third. Let's compare the third now. So now you are adding 6. So you have third term here in this sequence, which is p square plus 4. You have 13, and then you add 6. And then let's look at the fourth term as well. So you're adding 8 now, plus 8. So fourth term, you have 20 in the sequence that is given, and here you're adding 8 to get 28. So now for the pth term of this sequence is p square plus 4. Now I have to add something like I have been adding here. So these are all the values from the sequence given, and I'm adding some number to it to get the value in this sequence. So p square plus 4 again is from this, pth term is this. Now I have to add something. So if you look at the sequence, I'm adding 2 here for the first term. I'm adding 4 here for the second term. I'm adding 6 here for the third term. I'm adding 8 here for the fourth term. So each time I'm just multiplying the term number with 2 and add it. So 4 I multiplied by 2, which is 8, and add it here. Here I have term number 3. I multiply it by 2, which is 6, and I add it here. Here I have term number 2. I multiply it by 2. I get 4, and I add it here. So for the pth term, what will I add? 2p. So this will give you, that's how you will use this expression for this sequence to get the pth term for this sequence. So this, your answer here will be p square plus 2p plus 4. Part C is the diagram below shows the first 3 patterns in a sequence. The patterns are made from short diagonal lines. So you have pattern 1, 2, 3. Draw pattern 4 on the dotty grid below. So if you look at the first pattern and then you observe the second one, you basically draw the boundaries of the adjacent, uh, you can call these rhombuses, I guess. Looks like a rhombus. So you basically just add another row of rhombuses, right? So from this to get to this, I added another row of rhombuses below the one that is already drawn. So if you want to go from this to the next one, you will just add. So this side here is given, so you'll just add one more here. This side is the last one, so I'll add one more here. This side was the last one, I'll add one more here. So to get this, so to get the next pattern, pattern number 4. So let me just first draw this pattern again here. So this 3 here. So 1, 2, 3, and then I'll just complete this here. So right now I'm just redrawing this pattern 3. before adding the new shapes. So this is another 2 here, and then you have 1 here. So this is pattern 3. Now you have to draw pattern number 4. So let me add it in another color. So again, now you will just add one more to the last, like the lowest sides here. So you'll just add this row here. So for this, I will add like this. For this side, I'll add like this, and this, and this. So this will be your pattern number 4. The next part is complete the table below for the number of short lines in pattern 4 and 5. So if you observe this, the number of short lines and then pattern number here. So each time, so here you have pattern number 1, you have 4 short lines. In pattern number 2, you have 10 short lines. Pattern number 3, you have 18 short lines. So here you multiply it by 4 to get the number of short lines. Here you multiply the pattern number by 5 to get 10 number of short lines, and then here you multiply it by 6. 6 times 3 is 18. So 4 will be multiplied by 7. So each time you multiply by a number that is 1 greater than the previous number that you multiplied with. So 7 times 4 will be 28, and then 5 will be multiplied by 8 to get 40. Part 3 is find an expression in terms of t for the number of short lines in pattern t. So let's call the number of short lines in pattern 1 S1, and you have 4 short lines. How did you get them? You multiplied 1 by 4. For pattern number 2, you multiplied 2 with 5, and 5 is what? 4 plus 1. So each time you're multiplying by a number that is 1 greater than the previous number that you multiplied with. So for pattern number 3, how many short lines do you have? You multiply 3 with 6, which is 4 plus 1 plus 1, and so on. Pattern number 4, you multiply 4 with, you add another 1 here, so plus 1 and then another 1. So now if you observe this pattern for the number of short lines in a pattern number, you are multiplying the pattern number, which is 1 here, 2 is here, 3 is here, 4 is here, and so on. So for the tth pattern, the number of short lines in pattern number t will be equal to t, because you're multiplying the pattern number here, t multiplied by this. So now if you observe this, this is 4, 4 plus 1, 4 plus 1 plus 1, 4 plus 1 plus 1 plus 1. So there is a common difference, and this is a similar pattern that you have seen almost in every question papers. And also in the first part, we solved this similar pattern where you have a constant difference between each term. So you add a constant number. Here you are adding 6 to the previous term to get the next term, and here you are adding 1 to the previous term to get the next term. So I'm just talking about this multiplier. Let's call this number a multiplier that we are multiplying with. So the first multiplier is 4. The second multiplier is 4 plus 1. The third multiplier is 4 plus 1 plus 1. 4 plus 1 plus 1. So what will be the multiplier for the tth term? If you want, you can use the formula again, which is a plus t minus 1. Usually we do n minus 1 because we are looking for the nth term. Here we are looking for the tth term. So a plus t minus 1 into d, where a is your number in the first term. So the first term here is 4. So I'll replace a with 4, plus t is the variable that remains at it is, and t minus 1, and d is the difference. So difference here is 1. If you take the third term and you subtract the second term, you will get the difference, which is 1. So this will be equal to 4 plus t minus 1, and this will be t plus 3. So if you want, you can use the formula, or you can observe here as well that for mt, t multiplier for the tth term, you will have 4 plus. So you add how many ones here? You're adding 2 ones for the third term. Here you're adding just one for the second term. So each time you're adding one less than the term number. So here you're looking at the tth term. So you're adding t minus 1 ones. So for the third term, we added 2 ones. For the second term, we added just 1 1. So for the tth term, we will add t minus 1 ones. So this will be t 4 plus, again, same t minus 1, which will give you the same answer, t plus 3. So you can either observe the sequence and then create the formula for the tth term, or you can just straight away use this formula a plus t minus 1 into d, where a is your first term in the sequence, which is 4 here, and d is the constant difference. So difference here is 1. So each time you're adding 1 to get the next term. So your difference was 1. So you get the expression for the tth term for the multiplier. So coming back here, so you're multiplying it with t plus 3, and this will give you the number of short lines in pattern t here. So if you want to expand this, you will get t square plus 3t. And you can double check this as well. So let's say we want to see the number of short lines in pattern number, let's say 3. So if I substitute 3 here, so let me find S3. If I substitute 3 square plus 3 into 3, so 3 square is 9, and 9 plus 9 is 18. So this is 18. Similarly, if you substitute 5, you will get 40 here. 5 square is 25, and 25 plus 15 will give you 40. So this is an expression for the number of short lines in pattern number t. So this is t square plus 3t. So you basically just expanded this. You observe that each time you multiply with it, you multiply your pattern number, which is 4 here, 3 here. You multiply your pattern number with this constant multiplier here, which is increasing by 1 each time. So you found the expression for the tth term of the multiplier, which is t plus 3 here. So you simply got t, which is the pattern number, multiplied by t plus 3, which is the expression for the tth term for this multiplier. So 4, 4 plus 1, 4 plus 1 plus 1, 4 plus 1 plus 1 plus 1. So that gave you t plus 3. So you basically, for the tth term, you multiply this with this, which gives you t square plus 3t. Question number 6 is ABC is a triangle with AC 6 centimeters and BC 9 centimeters. AB has been drawn below. Using a ruler and a pair of compasses only, construct the triangle ABC. So you're given that the point C is 6 centimeters from A and it's 9 centimeter from point B. So I will use my compass and ruler here. So first I will open it up until 6 centimeters to mark the point of position of point C with respect to A. So let's open it up till 6 centimeters, and then I will center my compass at point A like this, and then draw an arc. So this arc represents the locus of points that are 6 centimeters from A. So all the points on this arc will have a distance of 6 centimeter from point A. And then I will open up my compass till 9 centimeters now. So up till 9. And now I will center it at point B here and draw another arc. Now this will be the locus of points that are 9 centimeter from B. So where these two arcs intersect, that will give me the position of point C. So this intersection point here will be point C. And now let me join this point C with A and B to get the triangle. So I will draw a straight line like this, and then another straight line from B. So this will give you your triangle ABC. The next part is measure the angle BAC. So now I will use my protractor here and center it at this point. So this is the angle BAC that we need to measure. So I will center it at point A, and then my 0 degrees will begin from here. So I will align my 0 degree with this line AB, and now my angle BAC will be, so this is around 75, 6, 7, 8, 9, almost 79 or 78 degrees. So I'll say it's almost 79. So my answer here will be that this angle here is 79 degrees, or this one here is 79 degrees. So that's how you will draw this triangle first and then measure the angle. Part B is a rectangular field has dimensions 220 meters by 350 meter, each correct to the nearest 10 meters. Calculate the upper bound for the area of the field. So you have this rectangular field here, and the dimensions are 350 and 220. So the area of this field will be the length multiplied by the width, right? But the question asks you to find the upper bound for the area. So for the upper bound of area, so since you're calculating the product of these two, you're multiplying your length with your width. How can you maximize the product here? If you take the upper bound of the length as well as the upper bound of the width, then when you multiply them, you will get the greatest possible value of the area, which is also the upper bound of the area. So you will have upper bound of length multiplied by the upper bound of width. So now we need to calculate the upper bound of length and width. So your degree of accuracy is 10 meters. So your error in your values of length and width will be your degree of accuracy divided by 2. So 10 divided by 2, you will get 5. So upper bound length will be, so let's call this the length, the greater one. So 350 plus 5, the error value. So you will get 355. And the upper bound of the width will be your width 220 plus the error value. So you will get 225. So now the upper bound of area will be the upper bound of length, which is 355, multiplied by the upper bound of width, which is 225. So you will get 355 multiplied by 225. This is 79875 meter square. So 79,875 meter square is your upper bound for the area of this rectangular field. So part C is PQRS lie on the circumference of this circle. PQRS is a trapezium. So these lines PQ and RS or SR are parallel. T is the point on SR such that this angle is 66, this is 35, this is 79. The first part is find angle PTS giving a reason for your answer. So angle PTS is this angle here. And so if you look at these two parallel lines, PQ and SR are parallel, and this line PT is intersecting these two parallel lines. It's passing through these parallel lines. So this angle, which is QPT, 66 degree, will also equal this angle PTS, because these two are alternate angles for these two parallel lines. So PTS is 66 degree because we can say QPT, angle QPT and angle PTS are alternate angles. Alternate angles. So this would be your reason. The next part is find angle PTQ. So angle PTQ is this angle in the middle, and we know that SR is a straight line. So 66 plus PTQ plus this angle 35 should equal 180 degrees because it's a straight line. So 66 degree plus angle PTQ plus 35 should equal 180. So this will give you angle PTQ as 180 minus 35 minus 66. So this is 79 degree. The next part is complete the statements below to show that triangle PQT is congruent to triangle RTQ. So PQT is this one and RTQ is this one. So these two triangles we have to show that these two are congruent. So first angle PTQ is equals to, so angle PTQ, so we calculated it as 79 degrees. So this angle is 79. So angle PTQ in this triangle is equal to angle RQT in this triangle because both are 79. So this angle PTQ is equal to angle RQT. RQT is also 79. The next part is angle PQT. So angle PQT, this one is obviously equal to this one here. So let me double mark them because these are also alternate angles. These two are parallel lines. This line is passing through these two parallel lines and these are alternate angles. So this will also be 35 degree. So this is equal to angle RTQ. Angle RTQ is same as angle PQT. All right. And then this length QT is common between the two triangles. So this triangle and this triangle have this length common. So we can say QT is common in both triangles. So triangle PQT is congruent to triangle RTQ. Congruency condition is AAS. You have two angles that are equal and the side between them is also equal. So you have in this triangle you have these two angles and in this triangle you have these two angles. They are equal and the side between them is also equal in length because it is common between the two triangles. So using the AAS property, that two angles are equal and the side in between them is also equal. So that means that the two triangles are congruent. Question 7 is the diagram shows the net of an open box of height 3 centimeter. The area of the base is 15. This length is x. The total area of the net is a centimeter square. Show that a is equal to this. So the base area is 15 centimeter square. So that means this other length. So if this length is x, the width, you can call it, let's call this width w. So x times w is equals to the area of the base of this box. So this is the base. So this is should equal 15. So w will be 15 over x. So this side is 15 over x and this side is 3. This side is 3 because these are all the heights of this box. So let me show you what I mean here. So if I draw an open box here, like this. So this side is x, this is 15 over x. So these heights are all 3 centimeters. So these are, if you open them like this and on the other side if you open them like this, or if you open the front like this, you will get this net. So all these heights will be 3. So all these dimensions will be 3 as well in this net. So now if we want to calculate the area of this net, I have 1, 2, 3, 4, 5 rectangles. I need to add up the areas of these 5 rectangles to get the total area of the net. So let's start with the base here. So area of the base is given, it's 15 centimeter square. So that is 15 plus. So let me first find the area of this rectangle here. So one side is 3 and this side is x, and this have this rectangle have the same dimensions. This is also 3 and this side is x as well. So there are two rectangles. So I will multiply the area with 2, and the area of one of these rectangles is length into width, x into 3. So x multiplied by 3. And then I have these two rectangles here. So let me go back and change the color. So this and this will have the same area as well, because one side is 3 and this other side is 15 over x, and this side is also 15 over x. So for these two rectangles, I will multiply the area by 2, and the area of one of these rectangles is 3 times 15 over x. So 3 into 15 over x. So now let's calculate this. 15 plus this will be 3x. 3x multiplied by 2 will give you 6x, plus 15 times 3 is 45. 45 times 2 is 90. So 90 over x. So you've shown that the area of the net is the same as given in the question. The next part is Graham has one of these open boxes. The total area of the net of his box is 65 centimeter square. Write down an equation in x and solve it to find the length of the base of Graham's box. Give your answer correct to 2 decimal places. So you're given that the total area of the net of his box is 65, and you have found that the total area is given by this equation. So 15 plus 6x plus 90 over x is the total area, which is 65. So this is the equation in x, and we will solve this now to find the value of x. So I'll take x as the LCM. So x will be multiplied here. So I will get 15x plus this will become 6x square plus 90 equals to 65. And then I will take this x to the other side. So I will get 15x plus 6x square plus 90 equals to 65x. And then if I bring this 65x here, it will be subtracted from this 15x. So I will get 6x square. 15 minus 65 will give you minus 50x plus 90 equals to 0. And then I can divide by 2 on both sides. So I will get 3x square minus 25x plus 45 equals to 0. And then we can use the quadratic formula. So let me continue here. So using the quadratic formula, I will get x equals to minus b. Your b value is minus 25. So minus minus 25 plus minus square root of b square minus 4ac. So b square will be minus 25 square minus 4ac. 4 into 3 into 45. 3 into 45 over 2 times a. So 2 times 3. So let me calculate this inside of the square root. So 25 square minus 4 into 3 into 45. So this is under root 85. So x will be minus minus plus 25 plus minus square root of 85 divided by 6. So x is 25 plus square root of 85 divided by 6, or x is 25 minus square root of 85 divided by 6. So here x will be 25 plus square root of 85 and then divided by 6. So this is 5.70, or your value of x here is 25 minus square root of 85 and then divided by 6. So this is 2.63. So both of these are possible values of x. You can write either one of them in the marking scheme. The correct answer is both of these are correct. So if you give any one of them, that should be fine. So I can write 5.70 centimeter as the value of x here. So the next part is complete the table below for a equals to this equation. So the value missing here is for x equals to 8. So if I substitute x equals to 8, I will get 15 plus 6 times 8 plus 90 divided by 8. So 90 divided by 8 is 11.25 plus this will be 8 times 6 is 48. So plus 48 plus 15. So this will be 74.25. So 74.25 will be your answer here. The next part is draw the graph of a equals to 15 plus 6x plus 90 over x for x between 2 and 8. So you're given this table up above here. I will plot this on this graph. So for x equals to 2, your value is 72. So x equals to 2, this is 72 here. Then for x equals to 3, you have 63. 3. So 63 will be in the middle of this small block here, exactly between 62 and 64. So this is 63. 4 is 61.5. 4 is 61.5. So here the value changes by 2. And how many small blocks are there? 1, 2, 3, 4, 5. 2 divided by 5. So what is 2 divided by 5? 2 divided by 5 is 0.4. So each small block here represents a change in value of 0.4. So for 4, this is 60, 60.4, 60.8, 61.2. This will be 61.6. So right below, just below 61.6 will be your value, 61.5. So for 5, you have 63. 5, you have 63 here in the middle. 6 is 66. 6 is 66, this one. And then 7 is 69.9. 7 is 69.9. So this is 70. This will be 70 minus 0.4, which is 69.6. So 69.9 will be right below 70, just below 70, more than halfway through this small block. And then 8 is 74.25. So 74, and then 74.4 is the next block, small block. So 74.25 will be around the middle of this small block here. So in the middle here. So this will be your 0.74.25. So now let's join these points to form the curve. So we'll start here. So this will be your curve for this equation. Part 3 is Delilah has one of these open boxes. The area of the net of her box is 68 centimeters square. Use your graph to find the length and width of the Delilah's box. So you have the area on the y-axis and x on the x-axis. So what is x? X is your width of your, oh sorry, the length, which is the longer one. So this side is longer, this side is shorter. So your value of x is on the x-axis. So when the area is 68, we need to find the value of x. So let's see, this is your line. So let me draw this in another color. So this is your line for 68. Your value here is 68. So it intersects the curve at this point and at this point. So I'll take this value, which is the larger of the two, because the value of x is the length of this rectangular box. So length is greater than the width. So length here is 6.5, 6.6. So it's in the middle of 6.5 and 6.6. So I can take it as 6.55 centimeter. And then to find the width, you know that the base is area is 15 and the width is 15 over x. So you calculated the width here, which is 15 over x. So your width here, width will equal 15 over x, 15 over 6.55. So 15 divided by 6.55 is 2.29. So you can say that this is almost 2.29, or you can write it as 2.30 as well. Both are fine. So 2.290. So this is how you will calculate the length and the width. Question number 8 is the grid shows triangle A and B and rectangle R. The first part is triangle A is mapped onto triangle B by the single transformation K. Find the matrix representing the transformation K. So now there are two ways to solve this. I'll show you both. The first one is through observation, and the other one is using the matrices. So let's first use the observation method here. So if you look at this triangle A, this is mapped onto triangle B, right? So by observing, you can see that this is not translation because the orientation of this triangle is changing. So in translation, simply the position changes, your orientation will remain the same. So this is like a right angle triangle. So for translation, it could move here, but the orientation remains the same. So this is not a translation. Also, the size remains the same. So this is not an enlargement. And then if you look at this triangle, if I rotate it like this, if I make this fall on this side, the shape will look like this, right? If I rotate it like this, and this is exactly how B looks. So that means this is a rotation. Some sort of rotation transforms triangle A onto triangle B. So once we know its rotation, we need to find the center of rotation, and we also need to find the angle of rotation, right? So now to find the center of rotation, you can connect any 2 points. So let's say I connect these two here. This point here is transformed onto this point, right? So let me join these two with a straight line. Let me draw this again. Okay, this is better. And similarly, let's take this point is transformed onto this point. So let me join. In fact, uh, yeah, let me join these two. Now, if you take the perpendicular bisectors of these two lines, the blue lines that I've drawn, the intersection point of the perpendicular bisector of these two lines will give you the center of rotation. So to draw the perpendicular bisector, I will take my compass here and then make sure you open it more than halfway and then draw the two arcs. So let me take this here, draw an arc here, and then on the other side of the line as well here. Then without changing the length of the compass, I'll place it at this point at B, draw an arc on this side, and draw an arc on the other side as well. So now if I join these two, this is my perpendicular bisector. This is my perpendicular bisector for this line. which is joining this object with the image. So this point was transformed onto this point. Now let's draw the perpendicular bisector for the other line. Oh, I don't need the ruler here. So I will use my compass again. Make sure you open it more than half the length of the line for which you are drawing the perpendicular bisector. So this is more than halfway. And then again, I can draw one line on this side and then another arc on this side. And then without changing the length of the compass, I will position it at this point and then draw an arc here and then draw an arc here. So this is like the point where the two arcs are intersecting. So let me join these two as well. And the intersection of these two perpendicular bisectors will give me the center of rotation. So yeah, this is the arc. So if you look at, I know it's kind of messy here, but if you look at these two perpendicular bisectors are intersecting at this origin 0, 0 point. So we saw that the two perpendicular bisectors were intersecting at this point origin. I have removed those just to make it a little bit cleaner. So now we know that the center of rotation here is 0, 0. Now what's the angle of rotation? So to find the angle of rotation, I will join the object, which is this one, this point, this vertex of triangle A with its image. And the image of this point is mapped onto this point, so I will join it here. Now, if you measure this angle, this is 90 degrees, and the rotation occurred in this direction. So this point moved from this point to this point. So this is angle is 90 degree anti-clockwise, right? So now you know that triangle A is mapped onto triangle B with a rotation with center of rotation origin 0, 0 and angle of 90 degrees anti-clockwise. So now you need to basically just find the matrix that represents this transformation of this rotation of 90 degree anti-clockwise about the point 0, 0. So you have learned the trick how to calculate the matrix for a certain transformation. So you draw the axis, xy axis, and you take the points 1 and 0 and the point 0 and 1. So when this point, let me actually write this in another color to make it look different. So this is 0, 1. So let's first look at this point. When it's rotated 90 degrees anti-clockwise, it will land at this point, right? So when you're writing the matrix, you write down the final image of this point first. So 1, 0 will land at 0, 1. So your first column will be 0, 1. And what happens to this point 0, 1? Once it's rotated 90 degrees around the origin in anti-clockwise direction, it will land here, which is -1 and 0. So this will be -1 and 0. So this will be your matrix that represents this transformation, which maps triangle A onto triangle B, which is actually a rotation about 0, 0, an angle of 90 degrees anti-clockwise. Now, if you can't see by intuition that this is a rotation, there is another method to solve this using matrices. So you know that once you apply transformation T to an object, you have object triangle A here, it is mapped onto triangle B. So if I multiply by A inverse here and A inverse here, I will get my transformation matrix T equals to B times A inverse, right? So let me write down the actual matrices. So the transformation matrix that we need to find is unknown. So let me call it A, B, C, D. And your matrix for A is the vertices of this triangle, right? So this is -4, 2, -4 and 2, -3, 2, -3, 4, -3, 2, and then -3 and 4. And then the corresponding vertices of triangle B are -2 and 4. So this was -4, 2. It is -4 and 2 is mapped onto this point, which is -2 and -4. -2 and -4. The next one is -3, 2. -3, 2 is mapped onto this point, which is -2 and -3. So -2 and -3. And the last point is this one, which is -3 and 4. -3 and 4. Oh, sorry. -3 and 4 is for triangle A. For triangle B, it is this -4 and -3. -4 and -3. Now to find this transformation matrix T, I need to find the inverse because I multiplied the inverse here to cancel it out, and BA inverse should give you the transformation matrix T. But you haven't learned how to find an inverse of a rectangular matrix. You have only learned how to find the inverse of a 2 by 2 square matrix. So what I can do is I can just take any two vertices of triangle A, apply the transformation, and I know that they will be mapped onto these two vertices of triangle B. So now I will get the equation ABCD multiplied by these two vertices of triangle A, -4, 2, -3, 2, will give me these two vertices of triangle B. So -2, -4, -2, -3. So now you just have to find the inverse of this 2 by 2 matrix and multiply it on this side here to cancel it out, and then on this side here to get the matrix ABCD. So to find the inverse, we need to first find the determinant. So let's call the determinant DET here. So determinant will be -4 times 2, -4 times 2, minus the product of these two. So -3 times 2. So this will be -8 plus 6, which is -2. So this will be your determinant. So your inverse will be 1 over determinant, which is 1 over -2 multiplied by the adjugate of this matrix, where you swap the positions of these two. So this will become 2 minus 4, and 2 and -4 are swapped, and you change the signs of the other two. So this will become 3, this will become -2. 3 and -2. So let me just write down the inverse here. So I will get, if I take this -1 by 2 inside, I will get -1 -3 over 2 -3 over 2. This will be +1, and this will be 2. -4 divided by -2 is +2. So this is my inverse right here. So I will multiply the inverse here on the left side of the equation and here on the right side of the equation. So this multiplied by its inverse will cancel out. So A, B, C, D will be -2, this matrix, -2, -2, -4, -3, multiplied by the inverse. Inverse is this here. So -1, -3 over 2, 1 and 2. So now let's multiply this row with this column. So -2 into -1 will be +2, and this -2 into +1 will be -2. So 2 minus 2 will be 0. So let me write it down here first. 2 minus 2, and then -2 multiplied by -3 by 2 will give me +3. And then -2 into 2 will give me 4, -4. So 3 minus 4. Then this row multiplied by this column will give me 4 minus 3. 4 minus 3. And then this 4 -4 multiplied by -3 by 2. So this 2 will cancel out with this 4. This will become -2. -2 into -3 is +6. And then -3 times 2 is -6. So this will be your matrix. So 2 minus 2 is 0, 3 minus 4 is minus 1, 4 minus 3 is 1, 6 minus 6 is 0. So you get the same answer as before. So your answer is 0, minus 1, 1, 0. So basically, if you cannot find by observation that this is a rotation, if you could, you find the full like center of rotation and the angle and the direction clockwise or anti-clockwise, and then you apply this trick where you take 2 points 1 0 and 0 1 and apply the same transformation and see where they end up. So they end up in this location. 1 0 goes to 0 1, 0 1 goes to minus 1 0. So this is your transformation matrix for the rotation that is applied to triangle A to get triangle B. But if you can't really understand by observation whether it's rotation, reflection, or whatever, you can use this matrix method as well, where you apply this transformation T to triangle A to get B. So to find the transformation T, you multiply the A inverse here and here. But since A is a 3 by 2 matrix here, oh sorry, 2 by 3, 2 rows and 3 columns, and you haven't learned how to find the inverse of that matrix, you can take the 2 by 2 matrix out. So you take 2 points x and y values and the corresponding image coordinates x and y values, and apply the same transformation ABCD to these two points here. So now you have a 2 by 2 matrix, and you can take the inverse of this, multiply the inverse on this side and this side. So you applied the inverse of this matrix here, and then when you multiply these two, you get ABCD, which is 0, minus 1, 1, and 0. So both methods will give you the same answer. The next part is triangle B is mapped onto triangle C by a reflection in the y-axis. On the diagram, draw triangle C. So the reflection in y-axis, how to find the image, how to like apply the reflection on this, you will connect each vertex to the line of reflection at a 90-degree angle. So if I connect this here, this already makes a 90-degree angle. Or not in, yeah, 90-degree angle. So for this, I will connect it directly here. This also makes a 90-degree angle. And for this point, it's also same. So just this and then so on. So let's start with this point. What is the distance of this point from this line of reflection? 2 blocks. So I will just go 2 blocks in the other direction. So if this is, let's call it A, B, C. So now this is B prime, the image. The image of C will also be the same distance on the other side of the line of reflection. So this will be C prime. And A prime is 1, 2, 3, 4 blocks away. So 1, 2, 3, 4 blocks away on the other side. So this will be A prime. So these are the 3 images of the vertices, and we can connect them to get our triangle A prime, B prime, and C prime. So this will be our triangle C. The next part is triangle A is mapped onto triangle C by single transformation L. Describe fully the single transformation L. So now A is being mapped onto C, and we have to find the transformation. So again, this is not enlargement because the size remains the same. This is not a translation as well because the orientation has changed as well. It's not pointing upwards like this. C is pointing towards the right. And this cannot be rotation as well, because if you try to rotate this A, if I rotate it like this, I will end up with something like this. And if I keep rotating, I'll get something like this. So the longer edge is pointing to the left here. But for C, the longer edge is pointing towards the right. So that means there's no rotation of A which can create this triangle C. So the only transformation left is reflection. So that means there is some reflection that maps triangle A onto triangle C. Now to find the line of reflection, we will join again. So let me use red color here. I will join the object with the image. So this point here of this triangle, this one here is mapped onto this point. So let me join these two. Oops. So now if I take the perpendicular bisector of this line here, that will be my line of reflection. Or if you don't want to calculate the perpendicular bisector or draw the perpendicular bisector like I've drawn this in the first part as well when we were finding the center of rotation. So for center of rotation, the intersection of two perpendicular bisectors give you the center of rotation. For line of reflection, the perpendicular bisector of this line, which joins this object with this image, this vertex with this image vertex, the line of, the perpendicular bisector itself is the line of reflection. So you can do that, or you can find the midpoint of this using the xy coordinates and find the midpoint of, let's say I join this with this. So this is another object. This vertex here is mapped onto this vertex here, like this. So the midpoint of this is this here. You can also use the xy coordinates. So this is 2 minus 3, this point here, and this point here is minus 3, 2. So to find the midpoint, I'll add the x coordinates. 2 minus 3 will be uh, minus 1 divided by 2. So you divide by 2. So add them and then divide by 2. And then for y coordinates, minus 3 plus 2 is minus 1, and then minus 1 divided by 2. So minus 0.5 minus 0.5 is the midpoint here. And then similarly for this, let's calculate the midpoint for this is minus 4 and 2. And this one is 2 and minus 4. So to find the midpoint, again, I'll add the x coordinates and divide by 2. Minus 4 plus 2 is minus 2 divided by 2, and 2 plus 4, 2 minus 4 is again minus 2 over 2. So your midpoint is minus 1 and minus 1. So minus 1 and minus 1 is this. So now if I join these two midpoints, I will get my line of reflection here. So this is the line of reflection. So you can either find two midpoints of the lines joining the object with the image and connect them to get the line of reflection, or you can simply join the 2 points, one pair of points, and draw the perpendicular bisector using your compass and ruler. So if you have drawn the perpendicular bisector, you would have gotten this same line. And what is the equation of this line? It's passing to 1 1 2 2 3 3 4 4 minus 1 minus 1. So this is y equals to x. So this is the line of reflection. So we can say that the triangle A is mapped onto triangle C by reflection in the line y equals to x. The next part is rectangle R is mapped onto rectangle S by a translation vector of minus 2, 3. So let me just erase this line here. So your translation vector is translation vector is minus 2, 3. So that means each coordinate will move 2 in the negative x direction and 3 in the positive positive y direction. So if I take this corner of this rectangle, this vertex, I move 2 in the negative x, 1, 2, and then I move 3 in the positive y. So 1, 2, 3. So this point will end up here. And then similarly, this point will move negative 2 plus 3. This point will move negative 2 plus 3. This point will move negative 2 plus 3. So these will be the 4 vertices of your rectangle R after the translation that is represented by this vector minus 2, 3. So your coordinates here are -1, 5, -1, 6, 2 and 5, and then 2 and 6. So this is your rectangle S. So you can mark this as S. Question number 9 is the diagram shows a sector of a circle of radius 8 centimeters and angle 70 degree. Calculate the area of the shaded region here. So this is the shaded area here. So the shaded area will be the area of this full sector minus the area of this triangle. So I can write the shaded area is equals to sector area minus the triangle area. So what is my sector area? My angle for the sector is 70, so it will be 70 divided by 360 into pi r square into pi into r square, and radius r is 8, so this will be 8 square minus the area of this triangle. So since this is the radius, this is also the radius, so this side is also 8, and the angle between them is 70 degrees. So I know the two sides of the triangle and I know the angle between them. So the area will be 1 by 2 into this side multiplied by this side, 8 into 8 multiplied by the sine of angle between them. So sine of 70. So let's calculate this. 70 divided by 360 multiplied by pi into 8 square is 64. So this is 39.0953, or let's say, let's round it out off to 4, minus 1 by 2 into 8 into 8 into sine of 70, sine of 70. So this is 30.070. So if I subtract this, 39.0954 minus 30.070. So this is 9.0254. So up till three significant figures, this will be 9.03. And the units are centimeters, so this will be centimeter square. So 9.03 centimeter square. Part B is a piece of chocolate in the shape of a prism with the shaded area of part A being its cross section. The rectangular base of the chocolate is 16 by x. The piece of chocolate is to be placed in a box which is a cuboid of size 16 by x by 1.5. Show that the chocolate will fit inside the box. So let me draw the box here. So the dimensions of the box is 16, so it's 16 in this direction, and then it is x by 1.5, so x in this direction, and then 1.5 in this direction, right? So this is your cuboid box in which you are trying to pack this. You're trying to pack this piece of chocolate. So this side is 16, which is fine. The chocolate has also the same side, 16. This side is x, which is also fine. The height of the box is 1.5 centimeters. So to prove that the chocolate will fit inside the box, we need to show that this vertical height, let's call this h, is less than or equal to 1.5 centimeter. If this height is greater than 1.5, then this box, this chocolate will not fit inside this box. So this is the height. And we are given that this shaded area is the same as this in the previous part. So let me redraw this here. So your shaded area was something like this triangle, and then you have the circle like this. This was your shaded area. This is 8, this is 8, and this was 70 degree. So now to find this height h, I can draw a straight line which bisects this angle of 70 degree. Let me draw this again. So this will be 35 degree. I know that this full length up till this point, this full length is also 8 because it is the radius of the same circle. So now this height h, this height is h. This h will be this full length 8 minus, let's call this length to be y. So this height h is 8 minus y. So if you look at this y length, it is part of this right angle triangle which has this hypotenuse 8 degrees, this angle 35 degree, and this base as y. So we can compute y here using this angle 35 degree. Cos of 35 will be base over hypotenuse. Base is y, hypotenuse is 8. So y equals to 8 times cos of 35. So let's calculate this. 8 into cos of 35. So this is 6.55. So your height h is 8 minus 6.55. So 8 minus 6.55. So this is 1.45. So clearly, if this is 1.45 centimeters, so you can say that height of chocolate is 1.45 centimeters, which is less than the height of box. Height of the box. The height of the box was 1.5. So it will fit inside. So it will fit inside. So that's how you will show that this piece of chocolate can fit in this cuboid box. The next part is these boxes are to be packed in cartons in the shape of a cuboid. The size of each carton is 48 by 4x by 24 centimeter. Find the maximum number of boxes that can be packed inside one carton. So let me first draw the carton here. So you have this big carton. And the dimensions are 48 by 4x by 24. And in this big carton, you're packing these boxes which have dimension x by 16 by 1.45. So this small box has dimensions 16 and x here and 1.5 in this direction. So now if I place this small box inside, how many will fit along this length? So this length is 4x, this is x. So 4x divided by x will give you 4. So that means along this length you can fit 4 of these. Wait 1 second. All right. So 1, 2, 3, and 4. And then along this length, this is 48, this is 16. So 48 divided by 16 will be 3. So along this length, you can fit 3 of these. And then in the height, along the height, this is 24 and this is 1.5. So 24 divided by 1.5 is 16. So along the height, you can fit 16. So this, along this length, you have 4. Along this length, you have 3. And along the height, you have how many? 16. So the maximum number of boxes that can be packed. So total boxes that can be packed equals to this 4 multiplied by this side 3, and along this side we can pack 16. So total we can pack 4 into 3 into 16, which is 192. You can also calculate this number 192 by dividing the volume. So you calculate the volume of this, divide divide by volume of this, you will get the same answer. But in this case it's fine using the volume method as well, because the smaller boxes completely fit inside this large carton. But if the dimensions were such that there were some empty spaces left where you could not fit any more of these small boxes, then the volume method does not work. Then you have to find how many you can fit along this length, and this length. So basically along each length you find how many boxes you can fit and then multiply them to get the total number. But in this case, since they are fitting in perfectly without leaving any empty space, you can calculate the volume of this cuboid, divide by this, you will get the same answer. Question number 10 is, a boat leaves A and travels 12 kilometers to B. The boat leaves at 10:25, speed is this. What time does the boat arrive at B? So first we need to find the time taken. So time taken will be equal to the distance, which is 12, divided by speed, which is 15. 0.8 hours. So I can convert this into minutes into 60. It will give me 48 minutes. So the boat takes 48 minutes. So it left at 10:25, and then you add 48 minutes to get the arrival time at B. 48 plus 25 is 73. So 73 and 10. So since I've gone above 60, I will minus 60 minutes here and add 1 hour here. So 73 minus 60 is 13, 10 plus 1, 11. So the arrival time at B is 11:13. Part B is the bearing of B from A is 56. B is 2 kilometers due west of C. Calculate AC. So AC is this length of this triangle ABC. I know two other sides. So if I can find this angle between them, I will know two sides of the triangle and the angle between them. Then I can use the cosine method. So to find this angle, so let me draw a straight line that represents north of B. So this is north, and then I'll just extend it below as well. So this is one straight line. This is north. So this will be parallel to this north. Now, if you look at this angle, which is 56 degree, and this angle, these are two parallel lines. AB is passing through these two parallel lines, and 56 and this angle here that I have drawn are alternate angles. So this angle here is 56 degree. And since B is due west of C, that means C is east of B. So that means this angle is 90 and this angle is also 90. So angle ABC will be 56 plus this 90. So ABC equals to 56 plus 90, which is 146. So this angle here is 146. Now, I know this angle is 146. I can use the cosine method. So cosine method will give me the length opposite this angle is AC square plus the sum of the squares of the other two lengths. So AB square plus BC square minus 2 times AB and BC. AB times BC times cos of this angle ABC. So this is, you will use the cosine rule to get this equation. Now I'll simply substitute the values. So AB is 12, BC is 2, and again AB 12, BC 2, cos of 146. So 12 square plus 2 square minus 2 into 12 into 2 into cos of 146. So AC square is 187.793, 7938. And AC will be the square root of this. Square root of this, 13.7. AC is 13.70 kilometers up till three significant figures. So you can write 13.70 kilometers. Part C is the base of a cliff. The top of the cliff D is vertically above C. So D is vertically above C. That means this angle is 90 degree. DC is perpendicular to BC. So DC is perpendicular to BC and DC is 105 meters. So this length is 105 meters. Calculate the angle of elevation of D from B. So angle of elevation is this. This is the angle of elevation of point D from B. Now this is a right angle triangle. BCD is a right angle triangle. I know the perpendicular, I know the length of the base, so I can use tan of angle DBC, which is the angle of elevation, equals to DC over BC. So tan of DBC is, DC is 105 meters, BC is 2 kilometers. So I will write it in meters, which is 2000 meters. So 15 divided by 2000 and then tan inverse of this. Oops. I think I made a mistake here. 105 divided by 2000 and then tan inverse of this. So this is angle DBC is 3.0 degrees. So this angle of elevation is 3.0. Question 11 is the grid shows this line 4y equals to x plus 2. By drawing appropriate lines, indicate the region R defined by all these inequalities. So the first inequality is x is greater than equal to 1. So that means I have to draw the line of x equals to 1. So x equals to 1 is this line here. The next is x plus y equals to 5. X plus y equals to 5. So let me write it down here. X plus y equals to 5. So when x is 0, y will be 5. When y is 0, x will be 5. So when x is 5, y is 0. So now I have the 2 points. I can draw this line as well. So 0 and 5 is this, and 5 and 0 is this. So this is your line, x plus y equals to 5. And then the third inequality is 4y is greater than equal to x plus 2. So this line is already given. Now you have positive coefficients of y in all of these equations, so you don't need to worry about this. But if you have negative coefficients of y in the inequalities given, make sure you convert them into positive coefficients or make y the subject of the equation that you form. Otherwise, you can get an incorrect answer. An example of this is in October, November 2016, paper 1, variant 1. If you look at question number 24, that question has a negative coefficient of y. So in that question, you need to first make y the subject of the equation or convert the negative coefficient of y into a positive one before you actually shade the region. Otherwise, if you do it by simply looking at the inequality, you can get the incorrect answer. So here in this case, I have positive coefficients of y in both of these inequalities, so I don't need to worry about this. I can simply look at the inequality and shade the appropriate region. So the first inequality is x is greater than equal to 1. So that means I'm looking at the right side of this blue line. Then the next one is x plus y is less than equal to 5. So this is the equation. Oh, sorry, this is the line for this equation, x plus y equals to 5. So the inequality is less than equal to. So that means I'm looking at region below this line. And then for this one, the inequality is greater than equal to. So this is the black line that I already have. So for this one, I'm looking at region above. So the region that I will shade here is this sort of triangle in between these three lines. So this is the region that is formed by these three inequalities. The next part is A is the point -1, 3, B is the point 5, 5. Calculate the length AB. So let's call this point x1, y1, x2, y2. So the length AB will be square root of y2 minus y1. So 5 minus 3 square plus x2 minus x1, 5 minus minus 1. So 5 minus minus 1 will become 5 plus 1. So this will be 4 plus 36, which is square root of 40. And that is 6.32. So this will be 6.32, the length of AB. The next part is find the equation of the line perpendicular to AB that passes through the midpoint of AB. So we need the gradient. So to find the equation of the line for this perpendicular, we need its gradient and we need one point on this line, right? So to find the gradient, I'll first find the gradient of AB. Gradient of AB. So I have these 2 points. Again, gradient will be y2 minus y1 over x2 minus x1. So this will be 5 minus 3 divided by 5 minus minus 1. So this will become 5 plus 1. So this is 2 over 6 or 1 by 3. So we know that so let's call this gradient of perpendicular. Gradient of perpendicular multiplied by gradient of AB. Gradient AB should equal -1 because we have learned that we've learned the property that if you multiply the gradient of a line with its perpendicular line, the product is -1. So this will give you gradient of perpendicular into 1 by 3 equals to -1. So gradient of perpendicular will be -3. And now let's find the midpoint of AB. So midpoint of AB will be you add the x coordinates 5 minus 1. So 5 minus 1 divided by 2 will be the x coordinate of the midpoint. And then 5 plus 3 divided by 2. 5 plus 3 divided by 2. So this will be 4 over 2, which is 2. This will be 8 over 2, which is 4. So now we know that the perpendicular passes through the midpoint of AB. So this 0.24 lies on this perpendicular line. And we also know the gradient. So the equation of this will be y minus y1 equals to gradient m into x minus x1. So this is the point I can use for my equation. This could be x1, this could be y1. So for the perpendicular, the equation will be y minus 4 equals to gradient is -3 into x minus x1 is 2. So let's simplify this. I will get y minus 4 equals to minus 3x plus 6. And then if I take this minus 4 to the other side, I will get y equals to minus 3x plus 6 plus 4 will be 10. So this will be the equation of the perpendicular line to AB. Y equals to minus 3x plus 10. So this is the perpendicular line to AB that passes through the midpoint of AB. This will be your equation. So this is the end of paper 2, variant 1 for May-June 2018.